Welcome to Chapter 2, everybody. This is a pretty exciting one for us. We really enjoy this stuff. We're going to hit the ground running here, so to speak, with the ideas associated with kinematics. So, what does that mean qualitatively? That means we're really going to try to connect these ideas of position, velocity, and acceleration, and really how they're related from a conceptual standpoint.
Yeah, but in addition to that, we also have to look at motion quantitatively. That means creating mathematical descriptions of things such as position, displacement, velocity, acceleration, and then manipulating those mathematical models so that we can apply them to real-world situations.
We're going to be spending a lot of time thinking about graphs. Now, graphs may be somewhat new or you haven't thought about them for a while.
But they can be your friend. Don't be afraid of graphs. They actually are your friends, provided that you read them carefully and understand what they're trying to tell you.
Yeah, I would say, there's a couple of really good slides. One of the ones that I would take a close look at is this slide that connects the notion of a position graph and instantaneous velocity. So in this particular case, we're trying to make the point here that the slope of the position versus time graph gives us the instantaneous velocity. Okay, so now you have to think a little bit about average versus instantaneous, so spend a little time on that. In this next slide, one of the things that we emphasize is that, yes, you can get information from the slope, but you can also get information from the area under the curve. Okay, now, we're not going to ask you to do any calculus, but one of the things we may ask you to do is to estimate areas. So there's a relationship between, in this case, velocity and the area under the velocity curve is related to the position. Okay, we're going to get a lot of experience with this, but if you have to go refresh your mind about what area under the curve means, please do so.
And in addition to discussing velocity, we're going to move on then and talk about acceleration. Now, this is a word you've probably heard many times throughout your life, but now we're going to have to give it a more precise qualitative and quantitative meaning. In this case, the change in velocity. Now, there's three ways to do this to an object. If an object accelerates, it could be speeding up, it could be slowing down, or it could be changing direction without speeding up or slowing down. And we also have to make our thoughts a little more detailed and a little clearer about what we mean by, say, positive and negative acceleration. For instance, if you look at this slide here, it talks about some of the different instances regarding positive or negative acceleration. And what you really have to remember is that you have to look at both the direction of the velocity, positive or negative, and the acceleration, positive or negative, to determine whether or not an object's speeding up or slowing down. In summary, the easiest way to think about it is if the velocity and acceleration are in the same direction, either both negative or both positive, then your object's going to be speeding up. On the other hand, if they are in opposite directions, velocity negative, acceleration positive, or vice versa, then the object's slowing down. Now the final question is, what if the acceleration and velocity are not in the same direction, not in opposite directions, but perpendicular to each other? That's a case we'll come back to later.
You're going to read a lot, you're going to do a lot with constant acceleration. Now this is a widely applicable model, and it's nice for a bunch of reasons. One, some of the equations that come out are really nice. Okay, we don't have to do too much, we don't have to do any calculus, but working with them builds an intuition, a connection between quantitative numbers and some of the qualitative things, the concepts. Now, the equations that we're going to see, we encourage you not to memorize them. You're going to work with them a lot, okay? And for those of you who are worried, we're going to give you these equations for, say, things like exams,
exactly.
Okay? So don't worry so much about memorizing them. We're going to spend a lot of time on free fall. Now, this is a special case of constant acceleration. So this is a really nice one to build intuition. Again, if you're sort of running into some problems, come and chat with us, okay? Because this is an important thing to understand, so if you're struggling with it, make sure that you come and chat with us, okay? We have a couple of final thoughts here. So as you work through this stuff, okay? One, take your time, Okay, we're just starting out. This is sort of our first meaty physics chapter. Okay?
The real physics starts here.
Yeah, so take your time. Okay, establish good working habits now. So if you haven't done so, please do so. Don't take shortcuts. If you have a question, okay, if you're struggling with something, spend a few minutes on it, and then come ask us a short question. Right? Sometimes that's all it takes. It's just a little bit of guidance.
And as we said earlier, if you can't find one of us, look for the other one of us. Or see if you can find one of the teaching assistants. They're always willing to help you. And as Nick said earlier, don't memorize the equations. It's not important. You won't have to. We're going to give them to you. However, you do need to know what those variables mean. At first, they may just seem like meaningless symbols, but every single symbol, every single variable has a very distinct physical meaning within this course. You also need to understand which equations are valid for which situations. Again, in this case of constant acceleration, there will be a number of relatively simple equations that are valid for those cases. However, if your acceleration is not constant, something we'll get to later on, those equations are not valid and you may not use them.
Yeah, for this stuff, one of the other things that we say is that there's no magic bullet for this stuff, right? There's no one text that you can read. There's no one problem that you do and for everybody it just sort of clicks. You have to do a variety of things, right? So try to interpret the graphs. Try to do the hard stuff.
And actually spend the time doing the problems, doing the examples. It's like trying to learn how to be a great free throw shooter by watching videos of doing free throws. It doesn't work that way. You actually have to dig in and do it. And as Nick said, there is no magic bullet. There is no pearl of wisdom. Look, if there was, we would have marketed it, we would have patented it, we'd be rich and retired.